Okay, we're going to look at another identity here that we're going to try and prove. We're trying to prove that the left-hand side here, 1 over sine x minus sine x, that it equals cosine x divided by tan x. So the way you start out is you're going to try and you take one side and you keep working it until you can get it to look like the other side. These are your rules that you have, that tangent is sine over cosine, that sine squared plus cos squared is 1. And therefore, sine squared is 1 minus cos squared, and cos squared is 1 minus sine squared. Those are all the things that you have to work with. Well, sometimes, and it comes up a lot in these, it's just being able to work with fractions is the key. What I do is I take sine x and I write it as sine x over 1. And then there's this key thing. When you think back, how do you add fractions? Well, you take the two denominators and you can multiply them together to get a common denominator. So whatever these two things are, multiply them together. Then you're going to multiply the top and bottom by whatever this denominator over here is. So B got multiplied by D. The top, A, gets multiplied by D. So this 1 gets multiplied by 1. Some people like to say you cross multiply. So now you take this sine x here and you multiply it by the sine x over there. That's how it became sine squared x. So 1 times 1 is 1. Sine x times minus sine x is minus sine x squared, all over sine x times 1. So there's the structure that you use when you combine a fraction. You always do that. Very often, not always, but you have to use this idea of fractions to be able to work these things out. Then you go, hey, 1 minus sine squared. 1 minus sine squared is really cos squared. So I can rub out the 1 minus sine squared and substitute in cos squared. Now I look what I'm trying to get here. I'm trying to get a cos x all by itself. So I can, instead of writing cos squared x, I can write cos x times cos x and put the sine x underneath one of the cos x. I can write it like that. It's still the same thing. But now I look at it and I think, hey, tan x is sine over cos x. So I've got cos x over sine x. If I put this in the bottom of the fraction, then I'm supposed to invert it. When you take a fraction and you put it in the bottom of a fraction, or you have a fraction in the bottom of a fraction, you invert it and multiply. So won't it work if I take cos x over sine x and I change it to sine over cos, and I put it in the denominator of this fraction? Well, now I've got it. It equals cos over sine x over cos x in the bottom. Hey, but sine x over cos is really tan x. And now I've made it look exactly like the right-hand side. So I'm finished this question. And I think that's enough for one. It's quite a bit of thinking. You might want to play the video a couple times to be able to figure it out.